Hi, welcome everyone. My name is Flora and I'm your host for tonight. Before we start tonight with the DevOps Meetup Amsterdam, I want to thank Henk Boelman, who made this all possible, that we can still deliver an online sort of meetup experience to you, even though we can't meet in person. So special thanks to Henk. If you follow along on Twitter, we're on DevOps AMS, so that's the Twitter handle that you can use. And Henk's Twitter handle is H Boelman. So if you want to give him a big thank you, that would be really nice, and I'm sure that he would appreciate it. Even though we're an online event and not an in-person event anymore, I would still like you to know that the code of conduct is still very much valid. If you're unsure what the code of conduct looks like, then you can go to devopsdays amsterdam.org/events/2020 Amsterdam/conduct, so you can have a look at what the code of conduct looks like, just if you need a refresher. Comments will be taken after every session, so the selection of the comments will be courtesy by yours truly. So we'll go through the comments during the session, and I'll make sure that the speaker gets the questions in our private control center. And the speakers can, of course, after their sessions, also engage in the YouTube comments. Then, if you'd like to speak at a next DevOps meetup, be it online or in person, who knows, please let us know. If you go to the website of DevOps Days Amsterdam, you can find an email address where you can reach us if you'd like to propose a talk. These talks will be recorded and we'll make them available shortly after. I have a sort of a co-presenter here who's hiding, so this is going to be a great, interesting meetup. Anyway, I'd like to start with Sarah's talk. Sarah is a backend engineer at DAZN. I've heard that I have to pronounce it that way today, and she'll be talking about failure modes in AWS serverless services. So, Sarah, there you go.
Hi, everybody. Can you hear me? Yeah. So my name is Sarah. I am a backend engineer in DAZN. I've been a developer over the last 9, almost 10 years. I joined DAZN 1 year ago, and as a backend engineer, I am contributor to shipping, developing, provisioning, monitoring all the microservices that power the DAZN platform. For those who are not familiar with DAZN is nicknamed the Netflix for sport. We stream sport events on real time and in demand. And most of our platform is powered by AWS, and within our architecture approach, we try to follow a serverless first approach. So that means that we try to simplify the delivery of our services by choosing serverless when it makes sense. Otherwise, we roll back to other solutions that can be ECS or Kubernetes sometimes. So today, I'm not going to talk about things like how we made a certain service very performant, or how we made the successes of the team that I belong to. Today I will talk about failures. So let me turn off the notification. Okay. So today we're going to talk about failures, and let's start with simplifying with serverless computing. Apparently, so they say, serverless is great because it simplifies shipping of new services. The alternative would be, if we don't choose serverless, that we have to provision an application load balancer, VPC subnets, EC2 instances, some data storage, whether this be RDS or any like data storage. And if we want to make it also reliable and resilient and highly available, we will have to deploy on multiple locations. And within a region, that means probably multiple availability zones, without even imagine like multiple regions. So I'm not even taking into account active architectures. So this is how more or less as an architecture that is not serverless oriented looks like. If we go with serverless, we have the advantage of creating, for instance, for a REST API, one API gateway, one Lambda, and by creating those two services, those services are already available in all the availability zones. So if I create one API gateway, one Lambda in new Central 1 region, AWS region, that service is going to be available in all the different availability zones of that particular region. And if we have a data storage like DynamoDB, which is a serverless solution for NoSQL databases, we have consistency through all the availability zones. So we have data replication out of the box, and that is a great advantage. So until now, I'd said it sounds like it's the solution to all my problems, right? Well, let's see. Let's start with a particular scenario, which is Lambda asynchronous invocations. When you have two Lambda, you can invoke one Lambda to another Lambda. One Lambda, let's say Lambda A, can call Lambda B in two different ways. You can call the second Lambda synchronously. That means that the Lambda A calls Lambda B and waits for the response. So it's hanging. The synchronous invocation instead just sends the event to the Lambda B, and Lambda A doesn't wait for the response, but it's just acknowledging that the event is dispatched. In the case of asynchronous invocation, what we don't know when we do this is that between Lambda A and Lambda B, there is an AWS managed queue that is in between. It's a proxy between the two Lambdas. So what happens if the Lambda B, if there is a failure in Lambda B, for instance, so the event is not correctly processed, the event is reprocessed multiple times and goes back to the AWS managed queue, and it gets retried to Lambda B by Lambda B a certain amount of time. So let's see a use case of one of the use cases that we encountered in the team that I was working in the zone. So we have two microservices. The microservice that you see on your left is a microservice that is a simple REST API that has an API gateway and a Lambda that gets a post request. And that post request is then processed. HTTP post request is processed, and an asynchronous invocation is sent by the Lambda post items to the Lambda generator. The Lambda generator is part of a microservice that is separated and has processed the information that gets from the previous microservice, and based on that generates some items, sends some email to stakeholders. And as part of the initial design, if something was going wrong, we would then send the failed messages, the failed events, to a dead letter queue. A dead letter queue is the managed queue that you can set that receives all the messages that were failed more than 3 times. This is an option. And yeah, so these are the limitations that we found. Every error was retried 3 times, and after 3 times, that message event would have been parked in the dead letter queue, which is the SQS one that you see. So everything looked good until we tried to promote our microservices to environments that were like staging. And so they were not our dev environments, they were more mirroring production. And the first thing that we noticed is that there was an abnormal number of timeouts on staging production. I say production because we were not live yet, but we were released into production as part of a dark deployment before the official release. So at this point, we were not live yet, but we were deploying. And so we noticed that there was an unusual number of timeouts. And what we figure out is that actually at the time, because we were testing so much the dev environment, the dev Lambda was always very warm. And I don't know if you're familiar with Lambdas, but there is a problem with the Lambda being warm or cold. If you don't invoke the Lambda frequently enough, the first time that you're going to call Lambda is going to take some time to get to process the request. Oh, sorry, not the request, but the event. So we noticed this. Another thing that we noticed is that we were unable to customize the number of retries, and that was a bit of a limitation. If you have like certain requirements for your service that you want to have more or less number of retries, that's a limitation that at the time last year we didn't have. Another limitation was that from a Lambda perspective is that there is a hard limit of 50 minutes for the Lambda. So Lambda is great if you want to process a very short amount of time, computing that takes a short amount of time. And in this particular scenario, we had a new requirement that would take more time than 50 minutes. And that was also that also got worse because of the coldness of the Lambda itself. So in that particular scenario at that time, unfortunately, we had to migrate from Lambda to an ECS-based architecture, and that is our output. So instead of a Lambda, we had to roll back from serverless, and we had an ECS poller, long poller, that would be integrated with an SQS queue that we ourselves provision, and the SQS that letter queue that was already there. But good news, because since last year, AWS changed this. So at this time, you are able to customize the number of the retry attempts. So now you can be between 0 and 2. It's still a limitation. So I think it would be nice to make the number of retries a bit higher, but that's something. Also, you can customize the number of age of events. So the time of in which the Lambda keeps the event into the managed queue up to 6 hours, which is great. Another nice feature that they rolled out recently is the Lambda destination. So you can decide when a Lambda takes an event from an asynchronous invocation. You can decide where this event will be dispatched as destination, both in case of failures, but also in case of successes. So that's great. Let's see another scenario, event source mapping. It's very similar to asynchronous invocation. In this use case, in this architecture, we would have one microservice that would have another REST API endpoint. In this case, the serverless solution was global DynamoDB table that would contain items integrated with Lambda via event source mapping, which is the Lambda data reporting. So the right side of your screen is a flow that is architected to do some data reporting for our data team. And the way event source mapping works is that all the changes that are coming from that are performed over the records of the DynamoDB table would be then transformed into streams of records that are then processed in batch by the Lambda. And even in this case, there is a managed queue that you don't see between the global DynamoDB table and the Lambda that is managed by AWS. Notice that also in this case, you can customize, you can have some things that are out of the box, but there are some services that are managed by AWS that you don't have power on. So everything in there happens between the global DynamoDB and the Lambda is managed by AWS. And in this case, something that happened is that we were noticing that we were not getting any data in our S3 bucket. So ideally, everything that was coming from DynamoDB was processed by the Lambda, that was processed by Firehose, that was ingested then in a S3 bucket, which is a data storage, where we would store some data in form of JSON. We noticed that we were not getting anything in the S3 bucket anymore. And what we noticed is that there was an error happening in the Lambda, and that error was basically keeping the managed queue that was between the global DynamoDB and the Lambda, and was blocking the process of new incoming records. Upon further investigation, we saw that there is an option to set up a destination for anything that fails in the Lambda, and it is possible to not put any on failure scenarios. So this is something not very optimal. I believe that AWS should probably make this on failure destination required, and the retry attempts. So if something would happen that's wrong in the Lambda would retry the same event continuously up to 10,000 times, and every time would be with exponential backup. So every time between each iteration would take longer, and that would block the entire queue. And that's not really optimal, because in case of failure, the batch is, as I said, in case of failure inside the Lambda, the batch is retried until either there is a success or the record expires. So these records will be processed or try to be processed up to 24 hours, and then they will expire, so you don't have them anymore, or the max retry limit is reached. This means that, you can block the entire process for up to 24 hours, and you can even lose data, and that's not really optimal. Another scenario is related to batch operation to DynamoDB. So between an ECS container, ECS task, and ingestor, let's call it ingestor, and a global DynamoDB table, we were trying to add some items in the table. And upon further investigation, we were trying to see, okay, how were things handled from a AWS side if something goes wrong while writing to the DynamoDB table, because as you know, there is some certain throughput that you have to satisfy when writing on DynamoDB tables. You can't just write as much as you want. So we investigated in the documentation. This is the AWS documentation as it was at the time, and as you notice, the error handling session is very hidden, nested a bit inside the programming with DynamoDB. It's there. So if you want to make sure that you're handling that scenario, it's not really easy to find that information. But if you open the page, this is the list of all the error scenarios that you can, all the errors that you can get by performing operation on a DynamoDB table. And why is this important? It's important because not all of them should be retried. So this is something important. Also, because if you want to write your test, if you want to see, okay, my unit test or integration test, what happens if Dynamo returns this particular error because of this particular scenario, then there is a lot of things that you have to take into account. Obviously, not all of the things in these items in this list are important. Not all of them are not important for the scope of your project. Only a subset of them, but you need to know the things can go wrong, and you need probably, if you want to implement the correct test scenarios, you want to know. So luckily for us, a lot of when you use the AWS SDK in OGS, you can expect that the SDK will take care of a lot of retry strategies for you. One thing that I figure out while working on this is that at the end, the SDK is a wrapper around HTTP calls that are done by the ECS task to the DynamoDB service. And the service is accessed via HTTP. So at the end, the operations are all HTTP calls. All the serverless services that are called using the SDK are accessed via HTTP calls. And the AWS SDK takes care of a lot of those retries, but not all of them. So some of them you have to take care of yourself. Another scenario that we notice is another scenario that we experience, sorry, is yet another REST API application service. And in this case, we have like an API gateway with a WAF and integrated with a network load balancer and an ECS task. And something weird happens. So we noticed from our dashboard and from our metrics that the API gateway was returning a unusual number of 500 errors after load testing, during a load test. So we investigated and we noticed that actually our ECS application was not returning any error. So the error was either the API was originated either via the API gateway or the network load balancer. And upon investigation, we checked the error logs, the logs for the API gateway, and we saw that all the errors were actually errors that were network errors. They were generated from the API gateway trying to communicate to the network load balancer and the ECS service. So we received a lot of 504 because the API gateway was not able to connect. And that is an error that it's caused by AWS itself. It was not generated by us. And it was very interesting to see that the service was not as available as we expected it to be. We open an API, so we open an AWS support and ticket, and the support, the person in charge of the support to handle the ticket explained to us that at the end, it is normal for AWS service to not be completely available. We expect AWS to be 100% available, but that's not the case. And if you go to any AWS service /SLA, this is something that I also, this thing I learned recently, you have a monthly uptime percentage that is limited. It's not 100%. It seems obvious, but it's not. And if you think about it, if you design your services using different AWS services, each of them has its own availability. So each of them contributes to the global availability of your own service, which is already partially unreliable. So choosing which AWS service is going to be powering or supporting your microservice, it's something that needs to be taken into account, the availability. If you go to the documentation of API Gateway, you will see that AWS tried to bring some guidance in terms of like how to handle error scenarios, including the 504, as you could see. And what is important to see in their documentation is that not all of them should be retried. Some of them not, some of them yes, and some of them only if the result, if you retry it different times, the result is the same, which is not always the case according to the context. So what are the learnings that we had during this, like each of these scenarios that we saw until now? First of all, observability is a must. To capture failures and to be able to either automate the handling or to react to it in a manual way, you need to have observability, you need to have metrics, you have to have logging. So observability is a must. Sorry. When you shift the responsibility to AWS and you rely on AWS serverless services, you offload certain responsibilities like VPC provisioning or operating system, setting up operating system or setting up clusters. This is everything that you can offload to AWS, but then you also lose control over certain configuration that you might need because of some certain requirements of your service. So you use control over the custom strategies that you might want to implement. This is something that I say often, like to me, writing code for distributed, that is supposed to be hosted on distributed system, is very tough. And I'd say 90% of my time sometimes 90% of my time is dedicated writing tests, and 10% is dedicated writing the actual business logic, just because the failure scenarios needs to be really captured. And when you have distributed system, you need to take into account that your dependencies might fail, and you need to react to it. Maybe you want to send some metrics, maybe you want to make sure that you're logging everything you need, maybe you want to make sure that you want to retry in case of failures. So if you want to cover these scenarios, it can be very tough and time consuming. As we saw in this journey, default settings of services are not always optimal. Sometimes AWS has certain settings by default that are not super, not maybe the best in terms of resiliency, sometimes security, but it's something that we need to be careful when deploying services. Is you need to read the documentation, and you need to make sure, okay, what happens if something goes wrong? How is my system going to react? This is something great. So in case of HTTP calls, the AWS, in case of calls to different services using the AWS SDK, the AWS SDK takes care of certain retry strategies for you, so that's great. But if you don't use the SDK, you need to implement your own strategies with backoff, and you need to handle different error codes in different ways, as we saw in the API Gateway documentation. Another important learning is that no system is 100% reliable. That includes the systems that are managed by AWS. These might have an impact over the availability of your own service, so be mindful about it. And to conclude, failures can't all be avoided. What is very important is that you need to prepare your system or to implement your system in such a way that the system is prepared to handle them. And that's it. Thank you. Do you have any question?
We have one question in the chat.
Nice. Which is? I'm sorry.
Right, do you want me
I don't
to...
have it in front of me.
Don't worry about it. Question is there monitoring in place for the queues? For instance, how long messages are in the queue, and what is a useful metric for this?
Yeah, so there are AWS metrics. Absolutely, yes. So there is the age of the oldest item. So that's very important, because when you park an item inside an event inside the queue, by default, there is a maximum time of retention, which is 14 days, which also it's a limitation. So you need to be careful that if something goes wrong, your failed event is handled before the end of the time. There is another metric which is called max iteration age. And that was actually the metric, the skyrocket, when we were doing the event source mapping between the global table, DynamoDB global table, and the Lambda. So the max iteration age of the Lambda was like millions, and there was, whoa, okay, that's a lot. Then other metrics, certainly failures in the invocation. So if the Lambda throws an error, is gonna generate some error invocations errors metric. So these are the top three that I have in my mind. But then, according to the event source mapping or this particular architecture, you might want to have something else in place. But these are the top three that I have in mind. Any other question?
Awesome. I hope that answered the question. I don't see any right now in the chat, but I propose that we do a little break for everyone to run to their fridge and get some refreshments, and then we'll continue with Stacy's talk. Thank you so much, Sarah.
All right. Thank you. Thanks. Woohoo!
That's wonderful. The
I feel so
enthusiasm.
I feel so relieved.
We're we're live though, but that's cute. So thank you all for joining us again. Next up is Stacy Cashmore. She's been a software developer since the mid 90s, and she's going to talk about and teach us all how to embrace our pitfalls. So.
Well, good evening, everybody. Thank you for joining us in these interesting conditions online. It's an interesting one to do. At Independer, the Netherlands' largest online financial advice website, we were late to the continuous integration and delivery party. We had a release flow, and it worked for us. It gave us a little bit of flexibility. We could do hot fixes when we needed to within a couple of hours, and we even had weekly releases. But it was also really cumbersome. There was a huge amount of manual effort involved in getting our website from our source control and into production. Some automation that we had already done in the past, it was simply PowerShell scripts. They had to be run manually and at the right time, or things broke. It was really quite fault intolerant. And on top of all of these things, our developers didn't know how our code got from our source control and into production. Basically, it was out of date. As developers, we wanted to work in a more modern way. We wanted to get fast feedback. We wanted to know that we were building the right thing and also know that we're building it in the right way. So we spent a lot of time, effort, sweat, tears, and of course, money to try and move the pipeline forward. So when we got through that journey, we were doing continuous integration and delivery. No, not really. Like a lot of companies, we were still at the start of our journey because moving to a real continuous integration and delivery flow, it's not only about the tooling, it's also about people. And people really struggle to make changes, even when there's a really good reason to do so. After all, we know that smoking kills, and people still smoke. We know that drinking is quite unhealthy, and people still like a drink. Motorbikes are maybe the most dangerous standard form of transport that we have, and I still love riding my bike, much to my mum's disappointment. Now, when you get people involved, things can take longer than we'd like it to. Sometimes the pace of change can seem glacially slow. You want to try something, you're there, you're running. And yet other people, they're still trying to find their feet. And even others are digging their heels in. They are actively trying to slow you down. I'm going to take you on the journey that we had through some of our trials, frustrations, and errors, and to say a little bit about what we've learned along the way. What I'm not going to be sharing with you tonight is a solution, because I'm afraid I don't have any magic solutions. I don't believe there is a single solution to these problems. Within one company, within one department, even within one small team, you have such a unique makeup of personalities that your challenges and solutions are going to be unique to you. But take a look at the mistakes that I did make and then go away and make your own new ones. Hi, I'm Stacy Cashmore. I've been a developer since the mid-1990s, and over that time I have worked in lots of different types of companies. I worked for Independer for nearly 14 years, and I'm really honored to say that when I first joined in 2006, I got to help implement that first real release flow that we had. Just before I left, I got to kill it. And I got to replace it with something far more agile and far more fault tolerant. In this session, I've got two stories to share with you, focusing on how we managed to improve our test automation and yeah, the issues that we had when we tried to do so. But before I get into my stories, I am going to mention the elephant in the room of tooling, because if we're going to automate, then of course we do need tooling. And with current technology, it's relatively easy. You've got lots of different tools out there that can help you. You've got Azure DevOps, Jenkins, etc. And you can build up a complete system to track your changes, to build your code, manage your deployments. You can even integrate your feature toggles so that you can code in a faster to master type way and get lots of insights at every step of the process. And none of that is going to help you at all if people are afraid and unsure of this new system that you've built. Because when that happens, they're going to find ways not to use it. And even a perfect system that gives you total visibility on everything, it's not going to help you that much if it's being used once a month for 1,000 file merge. So yes, tooling is super important in what we're doing, but it's not the silver bullet that's going to solve all of your problems. The people involved, they are just as, maybe even more important. And believe me, they can be a lot more difficult to take along the journey. Now, my first story, People Just Want to Help, stems from how easy it was for people to fall back into old patterns of working when we were trying to make a change. Why they fell back into those old patterns, and also the fun that you can have trying to take your team along the journey with you. In mid-2018, we made a decision as a department to try master-based development. Now, this caused a lot of fear, stress, even resentment among some people. And I was some people. I was quite fearful of the change we were making. I thought it was going to be impossible. I could see the issues that we had when we were dealing with the long-lived branches. And I just thought, if we have this every day, we're going to get nothing done. But I've missed the point. Moving to a master-based development system, that's not the thing that's going to solve all of your problems. What it is going to do is make your problems really visible, so you're going to have to change to make sure that things work. And that click in my head, that was a mindset change for me. I stopped being fearful about what we were going to do, and I started to get really excited about what was ahead, wanting to make it work, looking forward to the challenge ahead. In my team, we had some different views. Some people were still really worried about how we were going to make it work. And one team member, our tester, he was absolutely set against this. He just had a total fear of going backwards in our quality control. For him, the only way he could guarantee quality was to have long-lived branches and long test cycles. Now, because we were at total opposites with each other, we had some really difficult retrospectives. I feel so sorry for the other team members that had to put up with us. But eventually, and I'm not sure why, I'm afraid, but eventually we started to have some really useful discussions. Not just arguing with each other, but actually about why he had such reservations about this. Why he was so insistent that no other company in the world would ever dream of working in master-based development, and why we were being reckless even trying this, to the point of irresponsibility or even negligence. His point was, it wasn't possible to test anything, no matter how small the change, unless it was living on a long-lived branch where he could just test away until he was sure it was okay. He did concede that maybe in the future we can do this, but we've got to wait until we have full coverage. Full unit test coverage, full integration test coverage, and full end-to-end test coverage. Without perfection in these things, we couldn't even dream of starting. Me, I wanted to be a little bit more pragmatic. Our code base was huge, and there was a good portion of that was legacy code. Some of it was a decade old, and it was still doing what it needed to do. There was no reason for us to change it. So we're not going to rewrite it just so that we can put in the testing that we know we're missing. But maybe we can do some small changes without waiting for this perfection. The big changes, sure. Even I admitted we needed the security of knowing we weren't breaking things at that point. But let's be pragmatic. Let's see what we can change and move forward. And there's no time like now to get started with this. As a team, we were already playing catch up with our testing. As I say, we had legacy code, and for historical reasons, it wasn't tested. So we were working in a best effort basis to try and introduce unit tests and end-to-end tests so that we could have more faith in what we were doing. But there's a problem with best effort basis to try and improve our lives, and it's just not good enough. Whenever we're short on time, the first thing that gets dropped is our best effort things. And in software development, when you ever not short on time? So by doing this in this way, we weren't making life better for ourselves, we were just making it worse more slowly. So we decided if we really want to work in this way as a team, the only thing that we can do is make sure that as of today, this afternoon, all of our pull requests are going to be automatically tested. Whether that's unit tests or end-to-end tests, whatever we need to put in there, that's going to be part of the work that we do. This terrified our tester. He had visions of work piling up on his desk because historically, the test system we used for end-to-end testing, only the testers had access to. Developers couldn't see the tests, they couldn't write the tests, they couldn't even see the results when the tests were ran. But around this time, we'd also made a change to a new system. We'd started to use Cypress, which is JavaScript. It's code. We're developers, we can make our own tests here. We can use our tester to validate our thoughts behind our tests and to make test plans that we can implement. We discussed this and came up with a nice plan and went off to lunch before we did our sprint planning in the afternoon. When we returned, we started to look at our stories for the upcoming sprints. We were in the middle of some fairly major changes at this time, so we had a good idea of what we needed to do before we started. We only needed to see how we could fit together pieces of the jigsaw to make the best use of our time. I mean, there's always something extra. There's always housekeeping stories that can sneak in. Whether it's a change in the law, so you've got to make changes so your code is still compliant, or a third-party API that's making a change, and if you don't change, your code dies. Our product owner told us that we had one of these changes coming up. It was vitally important we made it, but it wasn't yet urgent. We could wait a couple of sprints if needs be. The major changes we were making, they were the most important, but if we could fit it in, please. A colleague of mine looked at our product owner and he gave an answer that I've heard so many times before and no doubt I'm going to hear again. Well, how about we just skip the automatic test for this one? We'll just add them again when we have time. I was shocked. I was so not impressed. I may even have sworn just a little bit. 2 hours. It had been 2 hours since we decided to make the change to our development process. That change so that we could more reliably make changes in the future, and that change so that we could give ourselves more trust in the changes that we were making. 2 hours. And here was somebody suggesting that we drop that discipline before we've even started. And it wasn't because he was being lazy, and it wasn't because he found it too difficult. He was suggesting dropping this because he wanted to help the business make one change more quickly. But of course, in doing this, everything else in the sprint would have taken longer. Our world would have been so much more complex. Instead of our tester helping us with test validation and writing test scripts, he would have been doing a huge amount of manual testing for this one small change. And again, 2 hours. The reason why we are making this change is still fresh in our heads. Imagine what it's like days or weeks in the future when it's not so fresh in our heads and this kind of thing comes up. That is the reason why he was dropping back into his old way of working. But I do want to stress, it was coming from a really good place. It was totally the wrong thing, but it was totally for the right reason. But that right reason, that gain in speed, it's really short-lived. You can do something quick and dirty today and be really quick. Later on, you might still be okay, but eventually you're going to have to crawl through the morass of all of these quick and dirty changes, and anything you do is going to be painfully slow, whether it's a quick fix or a real fix. And when you reach this point, who's the biggest loser? It's the business, the very person he was trying to help by dropping the discipline. Thankfully, our product owner was superb. She is fantastic. She was really behind the idea that we put forward, and she accepted what that idea meant for her. It meant that we were going to have to slow down at the start. We were going to have to learn new ways of working. We were going to have to learn new tools and new syntax. And we were going to have to get used to all of these new things on the job as we went along. Now, hopefully the idea is, of course, that as our coverage increases, we can get back to our old pace. We can reverse this. And you can reverse it with the knowledge that everything we write is already backed up by automatic regression tests. So any changes we can make with more faith, and we can also make them without hours of manual regression testing. So maybe in the future we can even speed up. And we got feedback on that much, much quicker than we were expecting. And it was positive feedback from our tester, the very person who was against changes to the way that we were working. At the heart of the mortgage software, we had a really complex algorithm. It's really complicated in what it does. It's really complicated in how it does it. And it's really complicated because it just has to talk to so many different services. Changing this was always a nightmare for us. If we had to change it, and believe me, we tried not to, it would be a week or more of manual regression testing to make sure that anything we did didn't break any functionality that relied on this one calculation and the myriad of values that it produced. Now, we were in a stand-up a couple of months after changing the way that we worked, and our product owner told us about a change that was upcoming. The tester gave us a look that I've only ever got from him in the past, really stern, staring at us, and said in a really gruff voice, "Does this mean that you've got to change that algorithm?" And we kind of looked at our feet and sadly went, "Yeah, I'm afraid it does." And he said, "Oh, okay. As long as the automatic test run, it'll be fine." I almost fainted. I really can't overstate how amazing that made me feel. I have told this story dozens of times in talks and in rehearsals, and I still get goosebumps at this point, just remembering that experience. We had spent just a little bit longer per change over the preceding sprints, and here we were with one complex change, saving a week's worth of manual testing. And on top of that, we had a much better feeling about what we were trying to change. Now, I'm not going to say that as of that point, everything was blue skies and sun regarding automatic testing, but I can say with some confidence from that point on, we got a lot better than we used to be. And as a team, we also learned not to fear missing value if we can see slowing down now is going to give more value back in the future. Now, my second story deals with a wider set of changes, looking for quick results in a change that we wanted to implement and dealing with a wider audience outside of my team, even outside of my department. In order to go on our journey to introduce continuous integration and delivery, we had a broad spectrum of changes that we needed to do. The way that we managed databases, the way we managed our servers, our deploys. And in order to cope with this, we introduced a CI mini group to focus on all of the different points. The problem was everybody in that CI mini group also belonged to an actual Scrum team, which meant, again, we were doing this on a best effort basis, and everybody has their own priorities in their teams, and it was difficult to spend the time needed in order to move this process forward. On top of that, we made milestones for ourselves, and we were waiting for too much perfection before taking the next step. We're waiting for everybody to catch up rather than showing the world what we were doing at a time when we could provide extra value back to the company. So a small group of us got together and decided, we think that we can get our releases fully automated and released on a daily basis for 95% of the time and mitigate the other 5%, and really allow us to get our value to production faster and limit the amount of time that people need to take for release because they're going to be smaller. We spent an afternoon trying to figure out the gaps in our process, what we needed to change, which automation we needed to introduce. And then we spent another afternoon putting together something to communicate to the business. We did say that this isn't something that we can just suddenly throw out there and go, surprise. Unfortunately, the business found out before we could talk to them. And we just got a short and sweet message saying, the business is not going to accept any more deployments than we currently have. Stop what you're doing. As one person in our mini team said, very courteously, that's really disappointing. Me? I wasn't quite so courteous. I started to write my thoughts in an email going a little more in depth in how I thought we should be handling this. And I pretty soon realized that, you know what, this email isn't 100% productive. I'm venting my frustration more than anything else. But it was venting my frustration. It was helping me. So I checked who I was sending it to, and it was safe. I wrapped my frustration in rant tags so people knew that I was just venting. And I even ended the email on 2 or 3 actionable points that would allow us to move forward without causing any problems. I thought this mitigated the venting. My manager disagreed. Cindy, I'm sorry. But the other people reading the email, they nodded along to it. It allowed them to open up and also vent their own frustration about where we felt we were being curtailed in what we wanted to do. So we spent an afternoon clearing our heads, having discussions, sitting, drinking coffee and complaining. And it felt really good because we're people. But on its own, it didn't really do anything for us. But it did work that stress out of our system and allowed us to take a step back and start to think, how can we work with this? We started to have direct conversations with the business, and we started to see where their real bottlenecks were. And it turns out the business weren't against daily releases. They were against the sheer amount of testing that it took to get something to production. Even more than that, there was a worry with part-time workers amongst them, people going on vacation, people being ill, that because we released everything in one blob, one person not being available could hold up the entire company, and nobody wanted that resting on their shoulders. I thought, this is great. This is really useful information. We've got a real bottleneck that we can see. It's tangible. We can get our teeth into it. At this point, that whole disappointment and frustration's gone. My brain has kicked into gear and I'm excited again to move forward. How can we change our current process to reduce the burden on the product owner and at the same time remove them as a bottleneck for everybody else? I did a couple of thought experiments trying to mitigate these issues and quickly realized mitigation is not going to work here. The only way that we're going to solve this problem is really by removing their work. And that meant a big change to our process. Now, I can't do this for an entire department. 30 plus developers and all the ancillary people around us. You can't run an experiment with that many people that simply. But I can do it with my team because we're 6 or 7 people and we can quite easily change the way that we work with agreement with each other. So I started to sketch out a few ideas of how we could reduce this burden of testing. but at the same time keep the paper trail that we had for the auditors, which is why the product owners tested in the release anyway. By using the better automated testing that we'd already started to do, we could actually try and move all of our testing left. Whether that's unit integration or end-to-end testing, try and move it to part of the development process and not part of the deploy process. Ask the product owner to join in our development process and test with us as we go along. And then because we have all of our automated testing in our release, the product owner knows that nothing's going to break before production. They don't have to repeat the same test over and over. And that means a product owner can actually spend their time validating ideas. Instead of just checking that we've put a yellow box on the screen, they can check that yellow box really solves the problem they think the users are having. And that gives a lot more value back to the company than simply repeating a tester's work, only without the same depth of knowledge as a tester. And when they know everything is correct and they know nothing's going to break in the release, or at least if it does, we're going to get notified, we actually used our product owner to approve our pull request for our auditing process to prove the business knew what we were doing. And we thought that was way better than just a flowchart in the release of everybody saying they've seen the same yellow box on the screen through the flow. And it had a wonderful side effect. If the product owner knows if things work or fail without manually testing, and the tester knows if things work or fail without manually testing, and the developer knows if things work or fail without manual testing, nobody has to approve the release, which is what everybody was doing previously. Developers can concentrate on our current work. We don't have to context switch back to what we were doing 1 or 2 days ago. Testers can spend their time writing their test plans, validating our testing ideas, and performing exploratory testing, things that provide loads of value to the team and the company. And on top of all of this, we can know inside of 20-30 minutes whether or not a deploy can go to production rather than waiting a day for it to go through the old chain. Result. Now, I ask myself still, the explosion that I did, was that the right thing to do? And I really don't know, but I'm human and it worked for me. And by limiting the people who saw my frustration, I actually allowed them to vent their frustration as well and move forward. And when we finished getting rid of all of that frustration, we could take that energy, that adrenaline, and we could pour it into finding root causes and solutions. We could use it to help, because if we didn't use it to help, we'd just use that energy to slow us down in the future. Now, on top of these things, I had a few light bulb moments when going through this process about where I started with the experimentation that I did for myself and for my team, how I dealt with people in my team, people outside of my team, and how I dealt with myself, because I needed to change too. I have learned so much from the experimentation I've done with my teams over the last few years, but it was tough for me to get started. What eventually got me going is just by looking at what was causing me the most pain, what low-hanging fruit was there that I could pick up. And as I started doing experiments and getting used to it, I started to feel more comfortable expanding the range of these experiments and making them more complex and including more people. And when it failed, and it's gonna fail if you do an experiment, you have to remember not to get disheartened by it. You need to take a step back, look at what went wrong, learn what needs tweaking, and then repeat your idea. And it's a cycle that you can do over and over until you arrive at something that works for you and you've got a great solution. Whatever you do, when you get this failure, don't take it as a sign that you need to stop and revert back to what you were doing before. Learn from it and use it to move forward. And once you get into the flow of doing experimentations and you want to make a bigger impact, share it with a wider group. I started this by just doing lightning talks within my department update, just 5-10 minutes, about the experiments that I've been working on for myself, for my team, what we were trying to achieve, what we'd learned, what had gone horribly wrong, and just tried to let others see that there's possibilities with experimentation and light that spark inside somebody else so they can start experimenting too. And when you do this, you have got to let your enthusiasm burn brightly inside you. You've got to let others see that this thing you're doing makes you so psyched. You get this knot in your stomach just thinking about it. Each step along the way, it fills you with that joy of success. Questions when things go wrong, and oh yes, just occasionally, complete and total frustration when nothing you do works. And remember that not everybody is going to feel this way about it. Some people, they're going to fight you tooth and nail for every change that you're trying to do. And something that I really had to learn going through this is that generally, these people are coming from a good place. They're not trying to sabotage any change that you're doing to improve your processes. They care deeply about what they're doing and they don't want to break it for no reason. They may see roadblocks that you don't. Sometimes they'll be wrong, sometimes they're going to be right. And I got more insight from my colleague, that tester, who blocked me at every step that I tried to do, than I did from the colleagues that weren't. I learned why they were concerned, and we came up with a joint approach that led us to a much better place. I'm not going to lie and say that we didn't get frustrated and annoyed with each other. Of course we did. But the joy at success when we did something together was fantastic. And a final thing that I had to learn when going through this process is, you know what? Some people just don't have this passion for change. Some people aren't going to get that knot in their stomach when they're trying new things, when they hear about new ways of working or new technology that can really help you. Some people want to come in, do their job, and go home at the end of the day. That's fine. There's nothing wrong with that. Just don't get discouraged by it when it happens. And that's easier said than done. Don't get frustrated by it. That is much easier said than done. And most importantly, don't let it stop you carrying out experiments and improving yourself if you want to. Thank you for taking this time to allow me to share my experiences with you. Take the lessons that I've learned and then go away and make your own mistakes with your own improvements. Learn from them and then share those ones with others as well. I'm sure Flo's going to be around to help with questions in a few minutes, or of course you can always catch me on Twitter at Stacy_Cash. I really hope you've enjoyed this virtual meetup. I really want to thank Flo and the team for setting this up so that we could still do this even with the world as it is today. It's been amazing. Good evening, everyone.
Yeah, and thank you for being so incredibly flexible, Stacy.
You're welcome.
So thank you for both Sarah and Stacy for being so incredibly flexible. I want to say a couple more words. I didn't see any questions in the chat. That's because I assume that everybody was just nodding along. It's everybody recognizes these stories, I think. And two more things. We have tentatively scheduled the next meetup for April 16th. So if you would like to talk at that meetup, then let us know and we'll schedule that. And then there's the topic of DevOps Days Amsterdam, which was originally scheduled for June 17 through 19 in Amsterdam. We're discussing basically as we meet up what is going to happen to the conference and in what way, if at all, it takes place. And you'll know when we know. So hope to catch you at the April 16 meetup. And thanks again to our speakers and to Henk for setting this all up. Have a great evening, everyone.